so this video is on tree reversals. All right, and so there's three different ways we will traverse through a binary tree. The first is going to be pre-order. The next is post order, and the last is in order. All right, and so a good way to remember the way these work is just think about the root, right? So if it's pre, that means the root comes previous to the others, right? So the order is going to be root, left, and then right, right? And left is always before right, right? So if it's post order, that means that root is going to come after, right? So that means we're going to have left, then right, and then root. If it's in order, then it's just going to be, in order from left to right. So it will be left, then root, and then right. All right, so let's look at an example of that. So let's take a look at pre-order first. All right, and remember pre-order is root, left, and then right. All right, so let's make a binary tree and let's go ahead and just see what a pre-order would look like. All right, so let me just create a binary tree here. All right, and so remember when we traverse through trees, we use recursive calls, right? So well, left and right will be recursive, right? So I'm going to first get the value of my root, right? And so my root is 10, so it will first print 10, and then we're going to do left first, right? And it's recursive calls. So it's going to recursively keep calling the left, right? So the next is going to be 5. Right? And then we're going to keep checking to see if we still have anything on the left. And we do. So we're going to go ahead and print the number 2. All right, and now 2 is a leaf node, right? So the recursion will now go and start doing the right, right? And so the right of this node, since we the last parent node was the 5, then we're going to go to the right of that node. So that will give us 7, right? And now 7 is a leaf node. So we finished everything on the left, and now we're going to begin the right, right? And so right, we get 13 first. Then we get 11. 11 is a leaf node, so now we go to the right, and we get our 15. Right, so that would be the order if we were going to do a pre-order traversal. So what about if we were doing a post-order traversal? Right, a post-order says we have this, right? Post-order, and a post-order says left, then right, then root. All right, so let's take the same tree. So let me just copy this tree. And if I want to go here, then go ahead and paste it. And let's put our tree here. So we are going to recursively go to our left. So right before we get to root, we're going to keep going to the left. So we are going to now have, we start at 10. Uh, 10 is not a leaf, so we go to 5. 5 is not a leaf. We get to 2, we have a leaf. So now we will print 2, right? And then we will go and print right, which would be 7. And then we print our root, which we have 5. Right, and so now we finished the left, and since post is left, right, root, then we are going to go to our right, right, and so we reach 13. 13 is not a leaf node, so we keep our recursion. Now we have 11 is a leaf node, and since we're doing left, right, root, so we go to the left first. So now we have 11. Then we are going to print the right, which is 15. Then we print the root, which would be 13. And so now both the left side and the right side have been completed. So now we print our root. And so we will get 10. So that is a post order traversal. The last one is going to be in order. All right, so if we have in order, and remember in order is going to be left, then right, left, then root, and then right. Right, and remember the left and right calls are recursive, right? So let's go ahead and paste that same tree. Over here, let's paste. So now we have our tree here, and now let's do in order. So in order says left, root, then right. So we are gonna recursively do our left, right? So 5 is not a leaf node. So we get to 2. 2 is a leaf node. So now we have 2, right? Then the next thing it says is to print the root. So that would be 5. And then it says to do right, which is 7. All right, so now we finished the left side. So it says left, root, right. So since we finished the left side, now we do our root, which would be 10. All right, and so we did our root. Now let's do our right side, right? So we go to 13. 13 is not a leaf node. So we keep traversing, and it's left, right, root. So we go to our left. We print out 11. 11 is a leaf node, right? So now we print our root, which would be 13. And then we print the right, which would be 15. All right, and so then that would be a in order. And if you notice, when you do in order, it is actually in numerical order, because that's the way we actually produce our binary tree. All right, so what does that look like in code? Right, so if we were going to write functions so that we want to print out our trees in post pre-order, is actually very simple, right? We pretty much want to go until we reach a null pointer, right? That's how we are able to detect that a node has not been set up in the tree, right? If it's equal to null pointer, that means that it hasn't been assigned to anything, right? And so since we build our trees, we build each of our nodes to have left and right set to null pointer until it actually gets a value, then all of our leaf nodes would have left and right the left and right node pointer set to null pointer. And so when we get a node that's set to null pointer, we know we reached a leaf. All right, so the secret word is box. So now let's talk about how we could write some of these functions. Right, so let's just think about what we're doing. Right, we said if the node pointer is equal to, I'm sorry, if the node pointer is equal to null pointer, then that means that we reached the end and there's really not anything else to do, right? So we can actually just put that as our stopping statement for our recursive call, right? So let's just say our parameter for this function, and we can go ahead and just create the function as well. And we're gonna do pre-order right now. Pre-order print. And our first parameter will be a node pointer. And I'm just gonna call this parent. Right, and then of course, that's actually all. We don't need to pass anything, so we'll just say node pointer parent. Right, so that will be the name of our function. So then let's just remember, right? We said if we reach a node, then that means that we know that we're at the end. So that is our stopping case for our recursive call. So we can say if parent is not equal to null pointer, then we'll proceed, right? If it is equal to node pointer, then we won't do anything that's inside this if statement, and our function will just end, right? So pre-order says what? It says print. It says print the root, then recursively print the left, and then the right, right? So we can just write that out exactly how the rule says. So if we want to print the root, we just say cout parent data, right? And of course, if you made your node a class, which I hope you did, then this might be a function, but remember this is just pseudocode, all right? So it says print the root, right, which is what we're calling parent, and then it says to recursively print the left and recursively print the right, right? So if we're doing recursive, right, we just call that function again, pre-order print, and it says to do the left first, right? So we're going to send parent left, and then it says to do the right, right? So we will just recursively do the right node afterwards. Right? And then that's basically it. And we have our print. And it will recursively send the nodes, right? And once parent left is equal to null pointer, then of course when it goes back to this function, then when it circles back to this function, it's not going to do anything because we only do what's inside this if statement if the node that's passed to the function is not a null pointer, right? So if you're having any issues implementing this, make sure that your left and right nodes default to null pointer. If they do not, then when it checks this condition will not return false, and you will probably get in some infinite loop, and you'll probably start seeing a lot of junk, or maybe you'll get a segment fault. You'll probably get some weird stuff happening. So it's important that you make sure that your left and right default to null pointer, and they only change when they get assigned when they start pointing to a new node, right? So just like pre-order, right? If you notice, we did the same order, right? We said print root, right? Then print left, and then print right. So writing the post order, I imagine you would you can figure out how to do that. It's this pretty much the same thing. We say void. We can do post order print, and we're gonna pass in a node pointer. We'll call it parent again. And inside this function, we're gonna do exact same thing. Well, this says what? Post order says left, right, and then parent, right? So we'll just go ahead and write our function to do the same thing. The same stopping case it will be for would apply to this function as well. So that would be if parent is not equal to null pointer, then we're gonna do exactly what we said. Remember, the left and right calls are always recursive. So we're gonna say post order print, and then we're going to put in parent left, and then it says right, so we're going to do the recursive call for right. So that would be parent right, right, and then we print our parent, right? So we say cout parent data. Right? And so the reason that this function works is because parent is just our parameter, right? So when we pass in parent, we are just printing out parent data, right? So if we want to print out the left, when we put in parent left into the function, then it actually takes the name of parent. So that's how we are still printing the left and the right. Not sure what just happened. That's how we are. That's how we're able to print the left and the right, because the left and the right comes back to the function, and then it represents the parent parameter. Right. So that's how that works. So I don't think I even need to do the in order, but I will. In order is going to be the exact same thing. Print. Then we'll have our node t pointer parent. And then this one says do the left recursive, the root, and the right recursive. Right? So if we do that, then we have same stopping case. If parent is not equal to null pointer, then we're gonna do what it says. So we're gonna do in order parent left, and then we're gonna print the root. So we'll say cout root, parent data, and then we'll do the recursive call to the right. All right, and so that is basically traversing through our tree. Very simple functions to write, and they pretty much just follow the rule, right? If the rule says that left is recursive, right is recursive, and root is just the root, then that's what we do. We do left recursive, right recursive, and then the root, we just print the root. So, what about, if we needed to traverse our tree, but we don't need to print What if we want to we want to traverse in order or post order or pre-order, but we don't really want to print. And actually, before I mention that, let me just talk about these functions as well. So, yeah, so of course we have in these functions we pass a node, right? But our users probably, the whole purpose of us making classes is so that the user wouldn't have to deal with nodes, right? What does a node actually mean to a user? A user wants a tree that is of some data type, like an integer or a string or whatever it is. They don't really need to worry about how to use a node class and then create a pointer to pass to it. In fact, if they pass a pointer to it, that pointer is actually not even going to be connected to the tree, right? So we don't want the user to actually see these functions, right? We don't want the users to see these functions. So we will create functions that don't take a parameter, and we will call that function. And then in that function, we pass the root of our binary tree class, right? So what I mean by that is we will overload, let's say in order print, for example. And in this in order print, I don't need to pass any I don't need to pass any variables to it, right? Because I'm just saying print my tree. So I don't need to pass a parameter to print my tree because this is a member function of my tree class. So all I have to do is just call my in order print function that takes a node pointer, and I just pass the root to that function. And so it will call this in order function with no parameters once, and then it's going to call the other in order print function recursively, right? Because that's a recursive function. And remember, this is a member function of our class, right? And so are all these. These are all member functions. I didn't write the class scope resolution because we're just doing pseudocode, but you should know that these are actually member functions of the class, right? So now when I'm in my main, if I'm in my int main, the user shouldn't really know that the in order print that takes a no parameter exists. So with that said, maybe this function needs to be private, right? Oh, excuse me, not this one. This one should not be private. This one should be public. This one should be public. But these here, right? These should be private functions, right? Because the user doesn't need to know about these. Your class will call those functions for them, right? So if I have my tree here and I say tree and I call it t, then all I really want to do is say t dot print, right? I don't want to have to say, oh shoot, how am I gonna pass in my, well, I'm sorry, not print, in order print, right? Whatever traversal we wanted to print. So I can say in order print, and I don't have to pass a variable, right? Because my in order print function automatically passes the root of my tree to the recursive function, right? We don't want to do something like this in order and then maybe try to, make a function to return our root, and say something like t dot get root. If we do something like that, we might have some issues with that, because of course, when we do get root, it's making a copy of the pointer. It's not the actual pointer. So sometimes you get some funky stuff like that. And then also, you don't really want to give your users access to your root. If they give access to your root, they can screw up your root, and we don't want that. And then your class can break, right? So we don't want to do something like this, right? But we do want to do something like this. All right, so that is how we will print our functions and the different traversals that we have. So now let me go back what I was talking about earlier, where you know we what if we want to traverse the trees in these different ways, right? In the different ways that mentioned here, the post order, uh, pre-order, post order, in order. But what if we don't need it to print a tree? What if we wanted to do something else, right? There's multiple things that we might want to do when we traverse a tree, and so when you're developing a tree, you have no idea what people want to do when they're traversing the tree. And so you can't spend your time trying to write thousands of functions to try to guess what they wanted to do, right? You know, we can keep writing a function, and instead of saying see out, we say, all right, now add the data to an array or something like that, right? So then we have to create a function, another function that says, all right, in order add to array or something, right? We have to come up with some really creative names, and we'll have to come up with thousands of functions to do that. So to avoid having to do that, we can actually have our function actually our function actually take a function as a parameter, right? And so the way we can do that, right? So let's talk about functions as parameters. All right, so the syntax for that is so let's say we're going to do the in order. I can say void, and let's just call it in order, right? I'll just call it in order, and then I can pass in a function. So I can say void, and then I can say f, right? And then I can say what the parameter of f will take. And of course, if we're templating, let's just say that'll be t, right? And we'll say a t reference, right? And so now I can traverse through my tree, and then every time I get to the place where it's supposed to do something with the data, I can just use this function to do something with the data, right? So let's just write the function again. If parent is not equal to null pointer, right? And since we're doing in order says we're going to do the in order recursive call. So we're going to say in parent left, right? Now we are just going to go ahead and call the function that we passed to our function, right? So now I'm just going to say f, and then I'm going to pass in the data from my tree as that function, as that function parameter, right? So whatever f is defined as, it will now perform whatever that function does on parent data, right? And then we just do our recursive call for the right, which will say in order parent right. And now once we do that, then we don't have to guess what the user wants to do as their for the in order traversals, right? The user gets to now define what they wanted to do, and they pass that function in as a parameter, right? So let's see what that would look like. So what if I wanted to make my in order function, let's say I want to make it add. So let's say I'm going to create an integer, and I wanted to just multiply the data by 10. All right, so then I can just create a function, and I can say multiply, whoops, multiply by 10. All right, and then of course it says that it's one parameter, right? This is defined as one parameter. So then I will just pass in, I'll say int number. And then in this function, all I'm going to do is say, and of course, it's a void function. So if I wanted to multiply by 10 and actually change the data, it needs to be passed by reference. So then I can just say num equals num times 10. Right? So now every time this in order is called, it will change the data and multiply it by 10. So when I use that for my function, then I just go into my int main, right? And inside int main, I will create my tree. And then I can just say t dot in order, and then I pass in multiply by 10. Right? And then let's say after I multiply it by 10, then I want it to print, right? So, now I don't even have to have an in order print function, right? I could just create a function, let's say void, print, and, let's give it one parameter, which is going to be an integer. So I will have my integer, I'll just call it num. And inside here, all I have to do is just say cout num. Right, so that is my print function. So now if I want to print my tree, I could do something like this, t dot in order. And then I can send in print. Right, and so now it will call that function and it will put all the data from the tree into this print function and print out the data. So with that said, really all we need to do is create our in order, post order, and pre-order functions. And then when we create our in order, pre-order print functions, really all we need to do is just, create another function. Maybe it could be inside, maybe we can put this function inside of our tree class, maybe as a private function. And then we can just create our in order print functions this way. Right, so our in order function is here. We can just say avoid f t num. Right, this would be our in order print function. Sorry, we don't need this here. I'm tripping. We just say in order print, and then in order print we'll just call in order print, and then we'll put in our print function. All right, so I just want to reiterate, when I did this example here, this was assuming that print was in main, right? And then when I did this example here, that's assuming that print is actually in your tree class, or at least in maybe in an unnamed namespace in the same CPP file as your tree class. So either way will work. So now you don't have to rewrite this function, right? You don't have to rewrite this function so many times. You rewrite it once, and then you can say print, and then any other tree traversal functions that you think you might use, you can do this same manner, right? Call the in order function and then just pass in the function, and voila, you have a bunch of ways to traverse through your tree and do different things. All right, so that's tree traversal. I hope you enjoyed the video. See you guys later.